For the practical visionaries at the Rocky Mountain Institute, there is no contradiction between meeting the needs of the market economy and drastically reducing waste and pollution.
A hypercar uses about 4 to 8 times less fuel than normal. It has 10 to 1,000 or more times less pollution than normal. In fact, it can have none at all. It has superior comfort, durability, safety, performance, acoustics, and therefore will be bought because it's a better car, not because it saves fuel and pollution.
These remarkable savings will come from the hypercar's hyper-efficient use of energy and materials.
The basic idea in the case of a car or similar vehicle is to make it 2 or 3-fold lighter in weight than normal by molding it out of advanced polymer composite materials instead of stamping it out of steel.
A car that is made of polymer composite instead of metal does not need a massive engine. Lovins and his colleagues envision a hybrid propulsion system combining electric motors with fuel cells. Hybrid engines, as demonstrated in this Toyota Prius, combine the driving range of a conventional gasoline engine with the efficiency of electric.
You power the wheels with special electric motors, but you make all the electricity on board from fuel as needed, because fuel has about 100 times as much energy per unit mass as batteries do. As usually happens when you design a whole system, the parts start to work together to give you more than the sum of the parts. Vicious circles turn into virtuous circles, and what you do to address or avoid one problem actually solves many more.
One problem is on almost every driver's mind: the chances of an accident. What will happen when an ultralight car crashes with heavy metal?
Indianapolis cars are made of carbon fiber, largely, and you've seen pictures of them hitting the wall and the driver get out and run away. The car gives its life to save yours.
Barring a major crash, a hypercar should last much longer than the 20th century car does. Like a computer, the hypercar will improve its performance through new software without changing its hardware. Just as the automobile transformed the economy and landscape of the 20th century, hypercars are likely to shape the world of the 21st century.
Ultralight hybrid cars will probably make the biggest changes in industrial structure since microchips. We think they will be the end as we know them of the car, oil, steel, aluminum, coal, and electricity industries, and the beginnings of new ones that are more benign and more profitable.